Welcome. So we're going to answer this question here. It says, the ages of 12 people doing a first aid course are shown in the set below. Here it is. The instructor randomly selects one person from the course. A is the event of selecting a person who's older than 18, and B is the event of selecting someone whose age is an odd number. What's the probability of A? Okay, this is where some color coding might be useful here. So if I want to figure out the probability of A, and that's selecting a person older than 18, that would be 20, 24, 25, 27, 28, 29, 30, 30, that, and that. Wow, there's a lot of them. There are 12 people and only 2 of them aren't, so that means it's going to be 10 on 12. So it'll be 10 on 12, which is the same as 5 on 6. You must simplify. That means the probability of B, now what is B? The probability of B is the event of selecting someone whose age is an odd number. Okay, so that would be, now I might represent this with a green dot. So that would be 17, 25, 27, 29, 33, 35. 1, 2, 3, 4, 5, 6. So that is 6 on 12, which is a half. Okay, next it says find the probability of A intersection of B. So that's where they intersect. So that means we're going to come over here and we're going to go, all right, where do they intersect? Well, there they intersect. That one, that one, that one, and that one. So 1, 2, 3, 4, 5. 5 out of 12, 5 out of 12, they intersect. Then it says find the union. Well, this is where we're going to have to use our addition principle to find the union. So remember, your union is equal to the probability of A plus the probability of B minus where they intersect. Okay, the probability of A was 5 on 6. The probability of B is a half. Where they intersect was 5 on 12. Remember, you got your CAS, so you don't have to do any heavy lifting here. We can just go 5 on 6 minus 1 on 2. Why did I say minus? That should be plus. Minus divided by 5 on 12. So that will be 11 on 12. Perfect. Next. Are A and B independent events? Justify your answer. For something to be independent, the probability of A intersection of B has to be equal to the probability of A times the probability of B. Okay, the intersection is 5 on 12. We found that out in part B. And that means if I was to take A, which we know is 5 on 6, and multiply it by B, which is a half, well, if you look at that, they are independent, because 5 on 12 is equal to 5 on 12. Therefore, independent. Cool. All right, let's keep on. Next part. Of the 12 people doing the first aid course, 7 are working full-time, 4 are studying part-time, and 2 are doing neither. Illustrate the information in the Venn diagram below. Okay. Now, we've got all this information here, and can I show you a little trick that I use here? I hate Venn diagrams. I hate them. I hate you, Mr. Venn. I much prefer Karnoff tables. I love you, Mr. Karnoff. Okay, so we're going to go W, not W. So that's working or not working, or studying or not studying. And now we can go, all right, there are 12 people doing the first aid course, 7 who are working full time. So in this one, I've got 7. 4 are studying part-time. So studying part-time, there's 4, and 2 are doing neither. So 2 is there. I know there are 12 altogether, 12 there. And now it's just a matter of filling in what I don't know. So that means here, this is going to be 8. This is going to be 5. This is going to be 3. This is going to be 1. This will be 6. Now I can come to drawing my Venn diagram, and you can see that I have all the information that I need. And do you see how the Karnoff map is just so good? I just love it. Like this 1 here is the intersection point. So that means I can put a 1 there. Then when it says, you know, what's this going to be? Now this is going to be W, this is going to be S. Now W is 7. If this is 1, this has to be 6. And that's just this information here. It's W, but not this. This S is S, but not W. So S, but not W, this will be 3. And 3 plus 1 is 4. Amazing. And then this number on the outside is 2. How easy is that when you use the Karnoff table? You're laughing. How many are working full-time and studying part-time? So that is the probability of how many are working full-time, so working and studying part-time, intersection of study. And you can see that's just the intersection point, it's just 1. What's the probability of randomly selected person who is studying part-time? What's the probability that a randomly selected person is studying part-time only? So that would be the probability of W. Studying part-time only. So it would be studying intersection of not working. Studying part-time only. Okay, so what's that going to be? That's going to be studying part-time only. So S W dash, it'll be 3 on 12. 1 on 4. Okay, we keep on going. Okay, last bit. What is the probability that a randomly selected person is not studying part-time given that they are in full-time work? Okay, so this is a given question. So the probability that a randomly selected person is not studying part-time, given that they're in full-time work. Okay, so that's the probability of S dash intersection of W over the probability of W. Now, if we come up here, we want S dash intersection of W. S dash. Do you see how I'm always using the Karnoff map? Just always. So this will be 6. And then the probability of W, you can also just take, if you wanted to, you can just take this W here. So it's 7. That's my answer, 6 on 7. That's it. We're done, people. That's how you do that question. Hopefully that made sense on how to answer this. Perfect. I'll see